Hi, my name is Henry Lee, and for my intelligent agents in the learning environment class, I'm gonna be talking about neural networks. Instead of covering the two videos that we watched for week one, I'm gonna cover one video, but I'm gonna go more into detail in that video. That video is called "What is Neural Networks" by Three Blue, One Brown. What is a neural network? A neural network is a computer system that is modeled after the human brain. What I mean by this is that we have many different artificial neurons that are all interconnected and they work together to think or to form a conclusion. How do we go from the input to the output? And one problem that uses neural networks is image recognition. How does image recognition work? Well, we first give an image as the input. That image is then split into its pixels, and we assign the same amount of neurons to hold the values of the pixels. And this value is based on the grayscale. So if it's black, it will be 0. If it's 1, or if it's white, it will be 1. And all the shades of gray in between will be decimal values like 0 0.3, 0 0.5, 0 0.7. Basically, the darker it is, the lower its values. The brighter it is, the higher its value. All of these neurons form the first layer, which is called the input layer, because those are the neurons that we get from the input that we give. And the number or the value inside the neurons is called its activation. The reason for this is because, well, if it's 0, it will be black, so it's not going to be activated. If it's white, or if it's 1, it will be white, so it will be activated. If it's 0.7, it would like partially shade up, so it will be partially activated. And so how do we go from the input layer to the output layer? Well, the logic to calculate this is in between them. It's called the hidden layers. All of the logic to calculate the output is in the hidden layers. Using the neurons in the first layer, we calculate which neurons in the second layer light up using a particular formula. I'm not gonna talk about the formula for now, but later in the video, all you have to know is that all the neurons from this layer are used to calculate which neurons on this layer light up, and all of these second layer are like used to calculate which neurons are calculated in the third layer, and so on until like we reach the final layer, and this final layer is called the output layer. So how does a neuron light up? As I mentioned before, all of the neurons from the previous layer are used to calculate the next layer, but only a single one of them. So these two calculate this, these two calculate this, these two calculate this, these two calculate this. But you may ask, if we are always using the same neurons from the previous layer, how do we give in different values for the neurons in the second layer? Well, the answer for this is weights. We give them weights from going from one neuron to the next layer, from one neuron to the next layer. We give them different weights so that they could calculate or give us different numbers. So, for example, this this neuron, when going from here to here, 0.7, from here to here, 0.8, from here, from here to here, 0.9, from here, 0.3. We give each of the layers or each of the links like a different weight, and so the formula becomes like active weight 1 activation 1 plus weight 2 activation 2, and like yeah, we do all of this the same. We repeat the same process for all of the nodes in the first layer to the second layer. But like, how do we calculate weights, or how do we assign weights? Well, let's say for this particular neuron, it's only checking this particular area, the green area. Uh, if it's positive, or or like if it's inside the green region, we could give it like a higher weight or a positive weight. If it's outside of the shaded region, the red, we could give it like a negative weight. So even though like for example this one, even though the activation is high because it's brighter, we don't want it to count towards our calculation as much because like it's not in the region. So we give it a negative um, weight compared to this black square, which is outside, no, which is in the region, but like it's not shaded. So we're giving the higher weight, even though it has like a lower activation. So like because it matters more in the area that we want. And after we get the weighted sum, this sum, we input it into like a sigmoid function. And the reason for this is because the weighted sum can get like incredibly large. Even though like we're only using like value from 0 to 1, given like the insane amount of like neurons that we're working on, is bound to like get high. The sum is gonna get high. Like even if it's not 700, it could still be like 100 or 70. And the neurons only hold values from 0 to 1. Therefore, we put it into the sigmoid function, which will always give us a value from 0 to 1. If the weighted sum is like a high negative, like negative 75, it's gonna be closer to 0. Basically, the more negative it is, the closer to 0. The more positive, the closer to 1. And this makes sure that we're always getting a value from 0 to 1 in each of the neurons. And then like we could add bias to make it more sensitive. Say we don't want the sum to, or like we want the sum to only shine when the value is greater than 10. To make to do this, we subtract 10 from the weighted sum before we inputting it into the sigmoid, because like if the sum is lower, the value is going to be lower. Say without the 10, you get 0.8. But if you add the 10, it could drop down to like 0.6, for example. And we could give it a high bias to make it more sensitive to like to only um, to only be activated when the value is high.